Hi. If you ever happen to build a full stack application, you might have come across common terminologies such as testing, deployment, and all of these different terminologies are part of what we call as CI/CD, which is continuous integration and continuous deployment. Now, you might have used some external CI/CD tools specifically for your projects such as Circle CI, Jenkins, Travis CI, and all of these tools are great. But when it comes to handling things such as your API secrets or API keys, they can be a bit of a hassle, especially with respect to security. Especially if you have, like, let's say, a GitHub project and you're managing your project CI/CD with the help of these external tools. But that's why today we're going to be introducing about GitHub Actions, which is an internal CI/CD platform built for GitHub repositories that is very easy to set up for any of your projects that you might have hosted on GitHub. So today we are going to be exploring what exactly is GitHub Actions, and then we'll be also showing you live example of how it is very easy to actually set up a GitHub Action CI/CD tooling for your project that is hosted on a GitHub repository. So without wasting any further time, let's get started. So let's get started with what exactly is GitHub Actions. Now, before we move to the world of GitHub Actions, we'll just quickly understand what exactly is CI/CD. Although we have covered what exactly is continuous integration and continuous deployment in our previous session on what exactly is DevOps, we'll just do a basic summary of what CI/CD really is. So CI/CD, as defined, is continuous integration and continuous deployment, and it primarily consists of these 5 different steps. So part of the CI, which is the continuous integration, will consist of the steps of building, testing, and artifacting. So essentially, whenever you're having any piece of code that you're pushing to a particular repository, now before it is actually merged and it is deployed for production, the first thing that will take place is the code will be built. Now, main reason why we are doing is to understand in case there was any kind of an error inside of the code that you actually push. If there's an error within that, or let's say if you have pushed that piece of code, if it actually affects some other part of the code, you're able to actually see and check if that code actually breaks at any point of time. So by building the code, you're able to actually see that. Now, the next step involved in this process, which is the testing, is also really important because it will, of course, let you know if the code actually breaks at any point of time during this entire cycle. And in case it does, then you are able to actually go ahead and make changes to your code to ensure that your code is bug free, and you're able to actually then properly push your code changes without breaking any specific thing within your code. So that's the main part of the continuous integration. And with respect to the deployment, that's where, like, once you've actually made sure that yes, your code successfully builds and it also passes through all the different test cases that you have written for the code, then we can actually go ahead and push it to production. Now, of course, in case you're working on larger projects, you might have multiple environments inside of your project. That might include things such as development environment, the staging environment. So before pushing your application into production, the secondary stage would be the staging environment, and then finally you will be pushing your code into production. And once it is pushed into production, that's when your actual application will be accessible to the end customer or to the end user. So that's the main idea behind the continuous integration and continuous deployment strategies. And of course, the entire DevOps sort of consists of the dev, which essentially is planning and creating your code, creating into a package. And then, of course, the operation side is where we manage everything from the release cycle, configuring our release so that it is made public, and we can ensure that yes, whatever public version of the code that you're actually releasing, that is going to be proper. And of course, it is also scalable as well. And once you've actually done the release, to ensure that yes, the release was done properly, we are also having management in that. So there are a lot of different tools that help you to sort of monitor the performance of your application, to see how well the application is performing under sustained workloads. So all of that can be managed with the help of DevOps. So without wasting any further time, sort of brings us to GitHub Actions. So GitHub Actions is a continuous integration and delivery platform that allows you to sort of automate and build and test and also automate your deployment pipelines. So essentially what you can do with the help of GitHub Actions is create workflows that allow you to actually build and test every push that you make to your GitHub repository, every pull request that you make to your GitHub repository, and also then helps you to create workflows that essentially look at the deployed pull requests or the merged pull requests that are made in terms of your GitHub repository. And GitHub Actions are like, not just limited to DevOps. They allow you to run workflows whenever any events happen inside of your repository. So like, let's say there could be a GitHub action event that could run, or workflow that could run in case, like, let's say you change some labels inside of your code, or like, let's say even if someone is like creating a issue. So it's not just limited to the DevOps that we are speaking about. And that's one of the major benefits when it comes to using GitHub Actions over like some external, like, CI/CD platform tool. And of course, with GitHub Actions, you do get Linux, Windows, Mac OS virtual machines to actually run these workflows. And also you could use your own self-hosted machines to actually run these workflows as well. Now, any GitHub action will primarily have 5 steps, which are events, jobs, runners, steps, and actions. So essentially, these are the main components of your GitHub Actions. And whenever we are creating a new GitHub Action workflow, they could be triggered whenever an event actually takes place. So that's why we are defining these events. And the event can be anything. It could be opening of a new pull request. It could be like, let's say, an issue, like whenever an issue is being created. So essentially the workflow will have one or more jobs that could either run in a sequential order or in parallel. Now, each job will essentially run inside of a virtual runner, or what we call as a container. Essentially, it's a Docker container, or essentially it is like your self-hosted container. And essentially, each of these jobs will basically have one or more steps that either could run a script, or essentially when you will actually define an action. So the workflow itself is essentially a configurable automated process that will have multiple one or more jobs. So essentially these workflows are defined by a YAML file that you write inside of your repository. Now, the event is a specific action that triggers the workflow run. So activity could be like such as like, being able to create a pull request. And then a job is basically a set of steps within a workflow that allow you to execute inside of a runner. And each step that you basically define is kind of a shell script that essentially will be executed, and or an action that will be run. An action is essentially a custom application that has been written for a GitHub Action platform that performs a complex a task that you'll be defining. And of course, as we mentioned, a runner is essentially a server that allows you to actually run these workflows whenever they are triggered. Now, let's take a look at each of these different steps as we cover them for events, jobs, runners, steps, and actions. All right. So now we'll start by actually creating a new repository on GitHub. So let's just give this name to the repository as let's say GitHub Actions tutorial. So I'll just call it GitHub Actions tutorial. All right. And I'll just make it a private repository for now. And I'll just add a README to get started. And as soon as I create, we should now see the repository being created. And now within the repository structure, the most important thing that we have to take note of is the actions tab. So this is where you'll find, or you can get started with GitHub Actions for your project. Now, of course, you can set up a workflow yourself, or you can actually use one of the predefined workflows that are provided for both continuous integration, deployment. For example, over here, you can see some starter samples that have been provided for setting up GitHub Actions for, like, let's say, being able to deploy a Node.js project to an Azure web app, or deploy it to Amazon ECS service, or like, let's say, set up a Terraform CLI, or it could be like, setting up some kind of a Xcode build with Xcode. So there are all of these different examples that are provided. But of course, today we're going to be setting up our own workflow. So of course, just sort of recap, what exactly is the workflow? It's a configurable automated process that will help you to actually run one or more jobs. And these workflows are defined by YAML file. So essentially what you can do is that either you can, if you want to actually set up the workflow yourself, you can click on this button on set up a workflow yourself. And just notice as soon as we click this, the repository structure. So essentially all the workflows are defined inside the .github slash workflows directory in the repository. And you could essentially have multiple workflows, and that would mean that each workflow will be defined in a separate YAML file. And the more number of workflows that you have, the more number of YAML files that will be defining for your workflow. Now, of course, this gives you sort of a sample basic workflow to get started with GitHub Actions, but we'll ignore this for now, and we'll actually go ahead and create our own workflow. So of course, in order to create one, we just have to basically go ahead and create a new file, and that would be within .github/workflows. And let's say that the name of our GitHub action is going to be main.yaml, let's say. So this is where we are going to be defining our entire workflow. So there are going to be now the 5 different things that we are going to be adding to our GitHub Actions. That includes the event, job, runner, steps, and actions that we covered. So we'll be defining all of them in when we actually define our YAML file. So we'll go over them one by one and sort of uncover what exactly do each one of them actually mean. Now, the first thing that we're going to be starting off with as we define this YAML structure is the first thing that we are going to be adding is the name for the workflow. Now, this is an optional field, but essentially the first step that we're going to be adding is the name of the workflow, as that will appear within the actions tab within GitHub Actions. So we can start by saying, like, let's say the name of this YAML file, the name of this workflow is going to be first workflow. So this is what will actually appear when we successfully create this workflow, and once this workflow gets initiated, this is the name that will appear inside the Actions tab. Now, the next thing that we're going to be adding is essentially how will this workflow get invoked, or what is the trigger for this workflow. So for now, what we're going to be doing is, for that, we are going to be defining an on event. So that essentially tells the trigger, like when exactly is the GitHub action supposed to be triggered. So for that, we're going to be saying that let's have a push event. That would mean that whenever you push something to your GitHub repository, essentially a push event. So essentially, as someone pushes a change to your GitHub repository, or like, let's say that could also mean that we are merging a pull request. So whenever we are pushing to every specific branch, then this particular action or this workflow will be triggered anytime, like, someone actually pushes a code. So that's the next part, that what is that event that should actually trigger this workflow. So that is what we are defining. Now, of course, you could have multiple ways in which you would want this to take place. Like, let's say if it could be an on for, like, let's say merging a PR. So right now we're just doing it for a simple change to the repository. Whenever someone is pushing something, some change to a repository, that's what will trigger this particular workflow. Now, the next step that we're going to be adding is essentially adding our jobs. So basically, this is sort of the main portion, or sort of the main part of our entire cycle. So essentially, jobs is where we are grouping together all the specific jobs that will run inside of this workflow. So we are going to be defining them one by one. So the first thing that, of course, we'll define is we'll start by defining our jobs one by one. So, like, let's say the first job that we're going to be doing could be something like a build job, that whenever you push a change, there will be a certain build. So the first job that we're going to be defining is by the name of build job. Now, the first thing that you have to define within the build job is essentially the runner, right? So as part of the GitHub action, the first thing that we're defining is the first job, that is the build, that we have called build. Now, the next thing that we have to define is the runner. So that is something that we can actually define by mentioning the runs on. So this is what will sort of define that on which particular machine will this particular workflow actually run, or this particular job will actually run. So by default, we GitHub provides us with an Ubuntu machine. So we can just define Ubuntu latest. So this is basically a machine that will be spun up by GitHub. And whenever you actually invoke this workflow, this particular job will run on this machine or this container provided by GitHub, and it's an Ubuntu container. So of course, you also have the ability to have your own custom machine as well that you can actually define that can run this particular job. So like, let's say it could be a machine learning workflow that requires a lot more computation, which might not be possible to be provided by this Ubuntu container provided by GitHub. And so in that scenario, what you could do is you could basically set up your own cloud machine and then use that for this particular task. Now, the next thing that we are going to be defining are essentially the steps. So we have defined that, okay, this particular job will run on the latest version of the Ubuntu Linux runner. So the next step is to actually go ahead and share what are the different steps that run inside of this particular job that we have defined. So in case of the build job, what are the different steps that will be involved? So the next thing that we're going to be defining are the steps. Now, of course, for this simple use case, we are going to be using a GitHub action, which essentially just runs a sample action whenever you essentially push a code. So that particular action is known as the checkout action. So basically, it's known as the checkout action. So it's a very popular action that is used whenever you're like pushing out or pushing a particular code. It's just going to be checking your repository and seeing whether the workflow that you have defined for your repository, if it is actually able to access your repository or not. Because sometimes there might be situations where your workflow might not be able to actually access. So this is a very simple action. As you can see that this is you have been given an example for how to actually use this. So essentially this is using the actions checkout v3. Now you might like sort of wonder what exactly is this actions, right? So essentially there is an entire marketplace for actions that is actually there. So we can just search for actions marketplace on GitHub, and essentially you can actually create your own actions and then submit them on this marketplace, from where you can simply just go ahead and search for specific actions. We'll be seeing later in an example of how you can search for, like, let's say if you want to add a GitHub action for checking linting of your code base. So we'll be searching for that particular action. So the action that we're going to be using is simply just a checkout action that just checks if you have access to your repository, and that's what we're going to be adding in terms of our steps. So the first step that we're going to be defining is the uses. So essentially what we're going to be saying is that, okay, the first action that we're going to be defining is uses. And of course, the action that we would want to use is the checkout v2. So essentially what the uses keyword actually specifies is that this particular step will actually run whatever specific action that we are defining. So like, let's say in this case, we are going to be defining the actions checkout. And as the usage actually said, that we're going to be using the @v3, that's the version v3. So what this particular uses actually mean is that this particular step will run the v3 version of the actions checkout GitHub action. So essentially what this GitHub action allows you to do is just check out your repository on the runner and allowing you to actually run the actions on your repository. So this is what we are going to be doing in this particular case. And of course, you can give this particular step a particular name. So like, let's say that the name that we define is just like, for example, just running a sample GitHub action, run a sample GitHub action. And you can also give it additionally, like, let's say a message that will be there when this particular action actually runs. So the run keyword basically tells you, tells the job to essentially execute, like, let's say a particular command. So of course you could do something like, let's say just echo and just print something. So in this case, what we are going to be doing is that with run, since we are like telling it to specifically run a command on the command line. So in this case, let's define it as like, let's say just echoing this workflow ran successfully, like let's say. So this workflow ran successfully for this particular action. So essentially what this would mean is that once this action actually runs, with this run keyword, we are telling the job to essentially execute a command on the runner. And in this case, it will just print, or it will just echo this particular statement, that is this workflow actually ran successfully for this particular action. So this is what we're going to be defining when we actually run this particular GitHub action, this workflow. So another one that we can actually also potentially add is, like, let's say if you wanted to actually, like, simulate an error also. So we'll see how you could actually do that. But for now, we are pretty much good to get started. So what we'll go ahead and do is that we'll just create this file. And as soon as we create this, if we go to the GitHub Actions, you can see that over here, we now have actually created this create main.yaml file. And of course, what you can see over here is that we have basically gone ahead and, okay, basically it says that we saw an error. Let me just quickly check. All right. So basically I just made a slight mistake, and we can just edit this and remove this run. So this should work now. And then we'll just go ahead and we'll start the commit and remove extra dash from run. So we'll just go ahead and commit these changes. And as soon as we define this, we should now be able to go ahead and see the action. Okay. Now, if we go to our GitHub Actions directly and look at the GitHub Actions, you can actually see that we have the first workflow. That is the name that we had provided to our workflow. And you can see that over here, and you can see that workflow is actually running right now. And if I click on this, you can see that essentially it did run successfully. And within this particular workflow, we have the entire summary, which also showcases all the list of jobs that you will actually have within this particular workflow. And the job that we have is the build job. And over here, you can see that the way it started was essentially to first set up the job. And over here, then once it actually set up the job, it ran this specific GitHub action, that is the checkout @v3 action. And then it was able to run that sample GitHub action and then actually complete the job, right? And over here, you can see that we ran this particular command as we ran this particular sample GitHub action, and this is what was printed as part of, like, the run, as we described that what run does. And finally, it successfully completed the action. And now what you'll see is that one interesting thing is that for this particular comment that we created, there is now a tick mark, because this particular GitHub action actually ran successfully. So in case of a place where the action might not have successfully run, you might have seen a cross, and we'll actually see that very soon by seeing how you can actually simulate, like, let's say, an error. So what we'll go ahead and do is we'll just first of all just make, let's say, a small change to test this further. Like, let's say, let me just, like, edit the readme and just update the readme once, readme text, like, let's say, and see what happens. So if I go again back to the actions, you can see that now we have basically gone ahead, and once, like, we have actually updated, you can see a new particular for this particular commit, a new action workflow again has been invoked, because what we're doing is that whenever we are going to be invoking this particular action whenever there's an push event taking place. So since I just pushed the code updating the readme, you can see that for this particular workflow, this is the second workflow that we have run, and it runs successfully. Now, first, let's just try to simulate an error. Like, how does an error actually look like? So what we'll do is we'll go ahead and we'll edit our main YAML file. So we'll just go ahead and change this YAML file. And, like, let's say that we'll have a further step within this, and we'll say that the name to which we'll give it is like, let's say, simulating an error. So we'll just say simulating error. And of course, we'll show that how, like, this will actually run and how this will actually behave when we would want to showcase. So we'll say that run, and we'll say echo error taking place, like, let's say. And now, apart from just providing this, what we'll do is that we'll mention exit one, so that we can actually exit out of this particular workflow. So we'll just add this in the commit, and we'll say adding simulating error in YAML, and we'll commit this. And now let's go ahead and go to our actions again and look at what actually happens once we start running this particular action, this particular workflow. So of course, right now the host is being set up, and of course we have run all of them successfully. But over here you can see that when we ran this particular step for the simulating an error, you can see that we actually get an error message which says, like, process completed, because we used like the exit one. So the workflow could not complete successfully, and it came out and it rendered an error. And now for this particular commit, if we see, you can see a cross sign, because this particular commit, this particular workflow did not run successfully. So you're seeing this cross sign, and within the actions, you can actually see that this was an unsuccessful workflow run. So this workflow run actually failed. So this is how you can actually see that whenever, if a workflow is successfully run, then you'll see a green tick. And of course, if a workflow has not run successfully, then you'll see this red cross sign that shows us that the workflow run has actually failed. So this is an example for how you can actually set up a GitHub action very simply. Now we'll go actually deeper into how you can actually use some of these actions that are available in the marketplace to actually run, like, let's say, like a linting. You want to, like, let's say, create a GitHub action for checking whether the code that you write for, like, let's say, Python file, whether it is actually written properly with the accordingly with, like, it has proper indentation. So you want to actually check the code for linting. So what we'll try to search for is a very popular GitHub action by the name of super linting, which is a very well-known action. So it's super linter. So we'll just search for super linter, and this is the action that we are going to be using. So it contains a number of different linters in various languages. It has support for multiple languages. So an example today, we'll see how this will actually run for Python, like, let's say. So now, of course, for each and every action that you visit within the marketplace, you can see some table of contents where it also shows you how you can actually run this specific action as well. So specifically, if you want to actually use this as well, you can see that it shows you the way of actually installing and actually using this particular superlinter. So the way we'll actually use it is github/superlinter@ with this specific version. So we'll be actually adding this to our YAML file. So what we'll do is that we'll essentially create a new workflow file, and within that will be basically within workflows. So let's actually go ahead and do that. For now, we'll create a new file, and that will reside within the workflows. So, like, let's say we can call it Python linting.yaml. So .yaml file. So we'll call that this as that. Now, like, let's say the name that we'll give to the workflow could be linting Python code. This, like, let's say we'll give this name to our workflow. Then we'll again always invoke this particular workflow on a push event for now. Now we can start by defining our jobs. So, like, let's say the job that we define is Python linting code. So this is the name of the job that we are creating. Now, again, the first thing that we'll start off is by mentioning what particular runner would be there for this particular job. So, like, let's say it will be again the default one provided by GitHub, that is the one to latest. Then, of course, we'll just go ahead and give like, let's say we'll define the steps. So we'll define the steps over here. And of course, for the steps, we can simply go ahead and just copy this particular name since we are using the super linter. So we'll just go ahead and define this over here. And let's just use this. So of course, what we've defined is basically the name, that is superlinter, and this will essentially use the GitHub superlinter v4. Now, of course, what we'll go ahead and actually do this is we'll just save this particular linter, and we'll just go ahead and commit this file and see if we are able to actually run this. For this, what we'll do is we'll actually go ahead and create a sample Python file. So let's go ahead and do that. So we'll go ahead, and what we want to do is we want to basically create a new file. So we'll just wait for it to actually run. So over here, what you can see is that if you go to our actions tab, you can see that, of course, the one that we created for the workflow, specifically for the first workflow, that's of course, that did not run successfully. Right now, what it's doing is that it's actually running the second workflow that we have created, which is the Python linting code. And over here, if we actually go, you'll see that it is pulling the action that is the super linter action, and that is what is running right now. But of course, what we'll go ahead and do is we'll actually create a Python file. So let's go ahead and do that. So for that, I'll just quickly convert this into this particular GitHub web editor to just visualize our Python file a little better. So what we'll do is we'll just go ahead and create a new Python file. And let's just wait for this to complete. Yeah. And I think we can go ahead and actually create a new Python file. We'll just call it main.py. And for now, what we'll do is that we'll just simply have a simple print statement. And of course, we'll just say print hello world. And we'll just go ahead and commit this change, create new Python file, and we'll just go ahead and create this. And we'll go back to github.com and just check what happens within the actions. So right now, we can see that we have, of course, a particular action that is still running for this particular code. So it is actually running this particular action. And of course, for this one, it is successful. But we can now go ahead and check for the one that, of course, will be now more relevant since we have created this particular Python file. So it's now pulling the superlinter action, and then it will run this on top of our. So essentially what it's going to be doing is that it will search for all the different type of code files, whichever like language are supported. It will try to find code files for that specific language. In this case, since we have created essentially a Python file, it will be able to detect that we have a Python file, and then it will go through the code and check if there is any linting issue. Of course, in case there is no issue, then it will successfully run the workflow. In case it does find an linting issue, then of course it will mention that it is not able to actually successfully run the action, run the workflow, and it will present the error. And then of course, once you adjust the error, or if you make changes, then of course it will run successfully. So we'll just quickly go ahead and see once it runs this successfully. And then what we'll do is we will go ahead and ensure that we we are able to demonstrate this is an example. So of course, as you can see that it is running this workflow right now. And of course, for this particular, it was able to actually successfully run this since we just had a very simple hello print statement that we had written. And over here, what we'll try to do is that we'll try to go ahead and just add some additional code over here. So let's say just go ahead and do this. And instead, like, let's say we just add some extra spaces, we define some additional, like, let's say two variables with the name equal to 5, b equal to 6, and just add some random spaces. And like, let's say we say sum is equal to a plus b, and then like, let's say go ahead and say print sum. So we're just intentionally making our Python file a little wonky, and to check whether our linter actually works or our GitHub action actually works. So we'll again go back to our actions tab, and we'll see whether, like, this actually runs successfully or not. So again, what it will do is that since we have a push event, now it has started to execute. Again, of course, we'll go back and see for the main.py, of course, the linting Python code. So now it should actually be able to see the changes that we have, we have made. It will be able to detect those changes. And then since it's running a linter, Python linter, it will be able to detect, that the Python code is not compliant with the standard way in which you should actually write the code. So it will be able to detect that, and it will go ahead and not run this particular workflow successfully, because it is able to actually find that specific thing. Now, of course, your actions, while we wait for this particular workflow to run successfully, your action journey does not just stop over here. With GitHub Actions, you can actually also provide secrets, client secrets that you might define within your settings. So for example, if we go to a particular repository settings, you can see over here that we can have some specific actions, secrets that we can actually define. Now, of course, you can actually go ahead and have a specific action secrets that will be used by the GitHub Actions. Now, these secrets could be anything. It could be for, like, let's say an external API that you might be using. It could be certain deployment action keys that you might be using. So if we just go ahead and look at our actions, I guess it is actually running right now. So in this case, it was able to actually successfully run this. So let's see. Of course, in this case, it was able to actually see that, yes, all the files did have, it did not have any error. So let's try to actually simulate an example where we might actually have an error. So let's say that we are going to be adding, like, let's say extra space over here, and like, let's say over here. So we'll just go ahead and create this commit. And now let's see if it is able to actually detect. Of course, it will be running both our two different workflows that we have created. So in this case, we are going to be again running this, but of course, just to again share that, of course, the journey is not just limited to, having all of these different actions that we have. So as I was saying, that you can actually also have your own set of actions that you can define. And then, of course, if you have some secrets, you can actually define the secrets over here. Then, you be able to actually leverage and use them within your GitHub Actions. And the way to actually do that is essentially by basically mentioning what that particular secret is. As you basically will go ahead and define your action, you'll be able to basically mention or basically add that this is the secret that you actually want to use. So you can add secrets as well. We'll see in a later tutorial as we take some examples for actually setting up a GitHub action for a Python project, for a Node.js project. So we'll have some upcoming videos that specifically deal with these type of actions. So we'll be defining those as well. So yeah, I mean, we'll just go ahead and quickly see if we are able to, if our action specifically for this Python linting is able to detect that. So of course, right now it is pulling the superlinter, and then it will run the superlinter on top of the Python code. So it has successfully been able to pull the action, and now it will actually run for this particular workflow. So let's see if it is able to detect that, yes, linting is not properly done. So it is now actually searching for all the different files within this particular, and as you can see that there is no, again, no error detected. So it uses the GitHub supplementer at the version 4.9.4. Of course, before we move ahead, we can just also look at how the use case for this particular is being used. So over here, we can just copy these steps. And of course, there is another interesting piece over here with the secrets. So we'll just go ahead and replace the steps over here with the one provided for the sample. So of course, what we're doing is that first we're checking out code using the checkout at the rate v3 action. And then of course, then what we'll be doing is we'll be running the linter on our code base, for which will be using the super linter. And one interesting thing to keep note over here is the environment. So default branch, we can change it to main. Since we no longer use master, we'll use main. One important thing to keep in mind is the GitHub token. So we here, the way to actually access, like, let's say if you have a hidden token that you might have defined. So if we actually go to our repository and look at the settings, you can see the section for secrets where you can actually define some custom environment variables. And these can be accessed by our GitHub Actions directly within our repository itself. Hence that point. So over here, what you're going to be doing is that we are going to be actually accessing our GitHub token from our for our supplementer, and we'll just go ahead and create and commit this particular file. Now, of course, we have created this particular linter. Now, what we'll do is that we'll go ahead and create a new file. Like, let's say we'll just call it main.py, and we'll just for now say print hello world. For now, we'll just have a simple print statement. And like, let's say just we'll go ahead and create this print main.py. Now, if you go to our actions, now you can see that there are not just one workflow, but there are two workflows. So the second workflow is the one that we created for our Python, for a linter, which is the linting Python code. And so we have essentially two different workflows that are running for now. And instead of just the one that we created, the first one, which is the first workflow, we have two of them now. So now you can see over here is that within our workflow runs, we have the create Python linting YAML, which is created over here. And of course, the create main.py, which will be running on our main. So if we go to the one that we had created when we had created the file, over here, you can see that what it's doing is that it's first of all pulling the supplementer over here from the GitHub, and then it will be essentially what it will do is that it will scan your entire code base for language specific files, and then it will basically detect the language specific files and scan through the entire language specific file to check whether if there is any issue with linting or not. Now, if it does not find any issue with the linting, then of course it will run successfully. The workflow will run successfully. In case it does find any linting issue, then of course it will be able to report that. So in this case, since we didn't really have any file, it should actually just run this successfully. And of course, it did that. And we see that it ran successfully. Now, of course, it will be running on the Python file that we created. So over here, it is right now, again, pulling the file. And this should actually run successfully because, of course, right now, we just really have a single print statement within the Python file that we have created. So over here, you can see that it has started to check out the code now. And of course, it is running it will run the supplementer and check whether the code is correct or not, whether it needs to be whether it's required for any linting or not. Of course, it ran successfully. So we should see this particular workflow also run successfully for the Python linter. Now, of course, as you can see that we get the green tick. Now what we'll do is that we'll change our Python file, and we'll let's say add a function. So we'll say def add, and this will have let's say a and b, and then we'll say sum is equal to a plus b, and we'll say return sum. We'll define our a as 10, b as 5, let's say, and then we'll say add a comma b, and we'll define it in a variable sum1, and we will go ahead and actually print this. So we'll go ahead and print sum1, and now let's go ahead and actually just additionally add some error, like like let's say over here, add some spaces, extra spaces, just mess up with the linting, mess up with the structure of our Python program, and just comment these changes. And now we'll try to see what actually happens. So this is the workflow that we are going to be looking at, which is the linting Python code. So this should ideally be able to actually detect that the changes that have been made. Of course, this is running on push. So whenever you're pushing any changes, it will be able to detect those changes, and then it will detect the changes that we have made in the Python file. And of course, since it is not properly linted, this particular workflow should not run successfully. So it has completed the pull, and very soon it will go ahead and start to actually check out the code. So in this particular workflow, it should ideally not run successfully. So we should see a cross sign for this particular workflow. Now, while this particular workflow is running, another thing to just keep in mind is that over here, you can see the list of all of your different workflows that you have created. And you have the ability to actually go and either see the workflow file, or even like if you want to actually delete a workflow, you can very simply delete. And of course, if you want to create a new workflow, you can directly go back to this window that we had seen in the first time we had gone to the actions. If you want to use one of the pre-configured ones, if you want to use those, or like let's say if you want to create a workflow for yourself, you can do that. A lot of times you might have seen that, let's say whenever some contributors are contributing to an open source project, they're greeted. So one of the most famous ones is this greetings one. So if you wanted to, like, let's say add this, you can very simply use this greetings.yaml. So this, as you can see over here as an example, this one will be created whenever we create a new issue, or like let's say whenever we're creating a new pull request. So essentially what it is trying to detect is that if a new contributor is creating their first ever issue on a GitHub repository that has this particular workflow running, or like let's say pull request, it will be able to detect that. And we can see that by seeing over here that we have it for pull requests and for issues, and specifically when we are creating a pull request. So the idea is that we are seeing that particular repository token, and we are seeing issue that, whenever a person, a contributor creates a new issue, then it will display this message from the bot that, hey, welcome, will be displayed on that particular user's first issue. And similarly, when they create their first ever pull request, this particular message will actually appear for them on the pull request that they create. So this is an example where the invoking is not just whenever we are just pushing any changes, but if you're creating a new issue, or like let's say if you're creating a new pull request, you'll be able to actually see this. But I think now we should be able to actually see, as you can see, that the workflow did not run successfully. Let's go and look at what error message we actually got. So this actually failed during the linting one. So over here, you can see that the link failed because it also can show the errors, specifically that we have an error on line 2, line 17. Over here, you can see the indentation error that we had there. So of course, now if we go ahead and actually improve our code and actually go ahead and remove these indentation errors, which were earlier there. So now ideally it should work once we remove these indentation errors. So if I go ahead and make the structure better again, and I commit these changes, then it should successfully show us that now the linting will work properly. So this is essentially an example for how you can actually add linting. And of course, we have similarly this entire marketplace that we have for our actions. So let me just quickly show this specific point. So of course, this is just one of the actions that we have within the marketplace for our actions. And you can then search for specific actions for any kind of a use case that you want to have inside of your application. So yeah, I mean, that is essentially what is primarily all about GitHub Actions in a tutorial. Of course, this is not entirely about GitHub Actions. Of course, GitHub Actions expands much beyond just these concepts, but we'll be having dedicated sessions for understanding how you can set up GitHub Actions for a node project. So for example, if you had, like, let's say, a node backend project and you want to actually write custom test cases, you want to also, like, test how you can actually build the project. So essentially your workflow file will have an command for, like, let's say, npm build during the job, when it's actually running the job, for testing, for deployment. So we'll be seeing that when we cover GitHub Actions for a full stack project. When we are, like, let's say, doing for Python, we'll have dedicated sessions for how we can set up a GitHub action for a Python project, for a Node.js project, and similarly, and which we'll cover in much more depth how you can, like, have for deployment, for testing. So we'll be covering all of that in that particular session. But I hope that you enjoyed this particular session for GitHub Action. Of course, in case you have any questions, feel free to reach out to us on the comment section, or you can also reach out to us on our Slack as well. But thank you so much for attending today's session on GitHub Actions. And we'll meet you soon with more such amazing sessions related to CI/CD as well. Thank you so much.